graphs of polynomial functions. And we need a little bit of background in order for us to be able to answer some of the questions that are going to be asked of us here in a couple of minutes. But what we're going to be looking at is, it says for each function, we're going to sketch the graph, and then we're going to complete the information in the box. But as I said before, we need to have a little bit of background information. So there's 2 vocabulary words that we need to know before starting this investigation. We will talk more about them tomorrow. But the first one is the degree. Well, the degree of our function is going to be the highest exponent in that equation that we're working with. And then secondly, the end behavior, it deals with the direction that the ends of the graph are heading. So that the end behavior definition doesn't really, in words, it's hard to describe. So as we go into our actual examples here, it will be, I hope, a little bit easier to point out to you what we've got. In the very first one here, it says f of x equals 2x plus 3. And if you want to type that into your calculator, you can type that in. But let me remind you that this first graph is in the form of y equals mx plus b. So what does m stand for? Jordan? Slope. What does b stand for? Oscar? The intercept. It's the intercept. So when we look at this, our slope is going to be 2 over 1. Our y-intercept is 3. And again, you can type this in your calculator, but we go up 2 over 1, and we can go down 2 to the left 1, but roughly, we've got this graph of a line. And we want to answer a couple questions about this. And the first question is, what's the degree of this function? Well, remember, the degree is determined by the highest exponent in this equation. What's the highest exponent in this equation? In other words, what's the exponent on this x right here? Well, it's not written, so it's a 1. So the degree of this function is 1. By the way, this would be, I'm getting ahead of myself, but this is going to be a linear function. We just drew a line. The second part says number of turns. Well, do we ever turn on this graph? Nope. We've got 0 turns. Next question, number of x-intercepts. How many x-intercepts do we have? We actually only have 1 right here. 1 x-intercept. And I'm just now realizing that I didn't change this one here, but we've got end behavior from the left, I believe is the first part. And then we've got end behavior from the right. But when we look at this, the end behavior from the left, what direction is our graph going over here on the left? It's going downward. And so when we describe that, what we can say here is that our end behavior to the left is going to be 2, negative infinity. Because we're going to go down, 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 down. And then our end behavior on the right, well, when we look at our picture, we're going up, 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 up. We're going to continue on and on to positive infinity. And that's what we're looking at. The end behavior deals with the direction the ends of the graph are heading. Over to the right, we're heading up. to the left, we're heading down. Finally, when we look at this, is our domain of our graph all real numbers? And if you don't know, then your guess should be yes. Is the range of the graph all real numbers? And it also is yes. So in a moment, I'm going to pause the video for you to work on problem number 2 on your own. So take about 3 minutes and work on that one on your own. So let's look at problem number 3 now. And let's type that into our calculator. We have a general idea of what this is going to look like. So if we go to y equals on our calculator, and we type in x squared plus 2x minus 5, and we get that U-shaped curve, which we are familiar with. And we're going to sketch that on our grid. Nothing fancy. It's a sketch. What's the degree of this function? Remember from above, it's the highest exponent the polynomial has. What's the highest exponent our polynomial has, Oscar? 2. How many terms do we have on this graph? Tiffany? 1. And in fact, it's right here. How many x-intercepts do we have? An intercept here, and an intercept here. Our end behavior on the left. Are we going up to infinity or down to negative infinity? We're going up to infinity. And in fact, not only are we going up to infinity on the left, but over here on the right, we're also going to infinity. Both sides are going up. Is the domain of our quadratic all real numbers? Yes. But is our range all real numbers? And the guess, based on my tone of voice, is no. And in fact, it isn't. And one of the reasons that we know it's not is because we ask ourselves, do we have a high point on the graph or a low point on the graph? And in this particular case, we have this low point right here. So kind of where we turn, we've got the lowest point on the graph. So our range is going to be everything from this red point and above. Not asking us to define what that is, it's just asking us to identify whether we have a high or low point on the graph, which will mean that our range is going to be not all real numbers. Going to pause the video again and have you work on problem number 4 for about 3 minutes. So let's type in problem number 5 and look at that. So we go to our y equals and we type in 2x cubed minus 7x plus 1. And again, our only goal here is to sketch the graph. So we get an idea of what the picture looks like. It doesn't have to be fancy. And we're going to come over here and we're going to draw a picture. Roughly something like that. And you can see a good picture on your graph, so mine is not that good. but it will get us through here. What's the degree of the function, remembering that the degree is the highest exponent in our equation? So what's our highest exponent?
3.
3. How many terms do we have in this particular polynomial?
2.
How many x-intercepts do we have? We have 3. The end behavior for the left, are we going to positive infinity or negative infinity? We're going to the negative. We're going downward. When we look to the right, our graph is going upward. Is our domain all real numbers? Yes. Is our range all real numbers? It actually is. But don't be misled here, because usually what I say for range is, do we have a high point or do we have a low point in the graph? We have a high point in the graph here, the red dot. But our graph is going to continue upward to positive infinity. So there's going to be points lower. We also have a low point in the graph. But as we look to the far left of our graph, it's going to go downward towards negative infinity. So there's going to be points lower. So our range is going to be all real numbers, because there is not a high point or a low point in the graph. So I'm going to pause the video here for a few minutes once again for us to finish up these graphs on our notes, and then we'll come back and we'll finish with the summary. But we've been working on our own for a little while to fill out problems 6, 7, 8, 9, 10. But let's see if we can answer a couple of questions to kind of pull it all together for ourselves. And the first question says, what is the relationship between the degree and the number of terms? Any ideas on what the relationship between those two is? Oscar? I couldn't have said it better myself. The number of terms is always one less than the degree. If we look at problem number 2, it says sketch the graph for x to the 4th minus 3. So we go back over here and we say x to the 4th minus 3. And we look at a quick picture here. It kind of looks like one of our quadratics. In fact, I'm going to slide that in here just because I can. There's the picture of it. What's the degree of this function? Some of you could hold it up on your fingers and tell me that it's 4. How many terms do we have here?
4.
We actually only have 1. So the last answer was a good answer, but it doesn't have to be just one less term, but at most one less term. But that's what the next part of this is. It says, how is this different from the other 4th degree graphs? Well, if we go back and we look at problem 7 and problem 8, what we see on that is that in this particular graph, we only have the one term. The other graphs each had 3 terms. But really, what I want to make sure to talk about is problems 3 and 4, because it says what is similar about the even functions. Because specifically, I wanted to look at the domain and range. But what's similar about the even degree functions, if we go back and look at them? Let's be specific and look at the end behavior. The end behavior in even functions it's either both going to go to infinity or both go to negative infinity. If you look back at that on problems 3 and 4 and 7, 8, they either both go to infinity in even functions, either goes both, I want to get that both in there, both to infinity or both to negative infinity. But here's the important part from that. What was the domain and the range on 3, 4, 7, and 8? Well, the domain on all of them is all reals. But because they either both go to infinity on our end behavior or they both go to negative infinity on the end behavior, that's when our range is not all reals. And I'll say it again. When our end behavior both goes to infinity, to the left and to the right, or both goes to a negative infinity, on the left and on the right, our domain is still all reals, but our range will not be all reals. In contrast, when we look at the odd functions here, 1 through 5, 6, 9, and 10, what happens is that the end behavior goes in opposite directions. The end behavior is either to infinity and to negative infinity, or vice versa. The end behavior goes in opposite directions, just to save a little bit of space and time here. When that happens, when one goes up and one goes down, then in terms of our domain and range, that means that our domain and range will be all reals. Both of them will be. So if the end behavior goes in the same direction, range is not going to be all reals. If the end behavior goes in opposite directions, it will be all reals. But lastly here, and try to get this down, I know my time is running short at this point. But the last question, what is the relationship between the number of zeros and the degree? Well, on most of them, it looks like the degree will tell you how many x-intercepts there are. But did that happen all 10 times? It didn't happen all 10. On problem number 7, we had 0 x-intercepts, even though the degree is 4. So what happens is the degree will tell at most how many x-intercepts.